Let's look at another system of inequalities to solve graphically, only this one has a higher exponent attached, so maybe it's going to be a little bit harder. First, individually looking at the two inequalities, the top inequality, y less than or equal to 2, if we pretended that that said y equals 2, it would be a horizontal line. So y equals 2 is this horizontal line. Now, where things that are less than or equal to that, it includes the line, and it is also going to be stuff that would be below the line. So when we make it y less than or equal to 2, it would look like this. Below the line is true for y less than or equal to 2. Now I'm going to change it back to equals so that it is easier for us to see what takes place with the second inequality. On the second inequality, y greater than or equal to x squared minus 1, that square makes this a parabola, and the parabola has been shifted down by one place. So now first, let's graph just y equals x squared minus 1. There's the parabola. You can see that everybody has been shifted down by one place. Now, just like before, what I want to try to do, I want to test with 0, 0 to see if I want to shade inside the parabola or if I need to be outside of the parabola. So when we test with 0, 0, you would end up with 0 greater than or equal to negative 1. And that's true. So it's inside of the parabola that we're going to want to shade. If we look just at the parabola, changing this from an equals to a greater than or equals, you see that it is inside that we needed to shade. Now, where are both things going to be true? It's inside the parabola, but below our red line. So the places where they overlap inside the parabola, but under the red line, it would look something like this, where the area is purple with the shading. Inside the parabola, but below that line, that's where they're both true. Now, this is what is called a bounded region because it's closed in on every side. If you had an opening somewhere, it would be called unbounded.